Hi friends, in this video we are going to learn what are the memory reference instructions. In the previous video we have seen what are register reference instructions, and in the second previous video we have learned the instruction cycles and the type of instructions. So this is the second type. There are 7 memory reference instructions here: AND to AC, add to AC, load to AC, store AC, branch unconditionally, branch DS, and this is increment skip if 0. So this is branch and save return address. I'm sorry, this is branch and save return address, right? Okay. So in the first case, AND operation. Okay, we take 2 bits, any 2 bits of AC, and perform AND operations between them. So the first, there are 2 timing cycles, actually only 1 timing cycle involved here, T4, but these instructions cannot be performed in 1 timing cycle, so there exist 2 timing cycles for certain instructions. So generally when this memory reference occurs is when D0 is 1. So D0 T4, at D0 T4 time we get, for decoder D0 is a decoder 0, okay, and at timing T4 this whatever the memory in the address register is transferred to data register, okay. So there will be the AND operation between the 2 bits of AC. After completion of this instruction, we need to clear the start counter so that it goes again to fetch. So we are clearing the start counter to 0. Next, add to AC. The same case, we transfer the memory to the DR register. From there we add both accumulator and data registers bits. We get the carry or not. We may not get the carry. If we get the carry, it is stored in if flop. If we don't get the carry, it is added, and the same is stored in the AC register. Okay. Now load to AC. So load to AC is directly loading the whatever the memory instruction into the accumulator register. So why we need to do this? As we see the control bus, there is no connection, direct connection between AC and bus, right? Accumulator and bus. So we need to go in the indirect path. What is the indirect path is, take the memory, store it in the data register, then after that you send the same data from data register to the accumulator, and again set the counter to 0 so that it completes the execution part. Storing the AC, directly store the AC memory to AC data to the memory of the register. This is branch unconditionally. That means this is, if you want to directly go to certain instruction in the program, then we will be using this. Okay. So directly storing the address register into the program counter. Okay, that it directly goes to that instruction without undergoing the starting instruction, without going into the first instructions. And after that setting my counter to 0. The next is branch and save return address. Okay, so in the first case, program counter is, the address in the program counter is sent to memory address, and incrementing the PC counter for the next instruction. In the D5 T4 step, whatever the program counter is there, it is sent into the memory address and incremented AR register. Then after that, AR is sent to the PC. This is again counter is set to 0. Now increment skip if 0. Okay, so here DR, whatever memory in the address register is set into the DR, and as it is increment operation, we increment DR. Now the result of the operation, and the result is stored in the memory address again. Okay, if the result is incrementation, result is 0, then I'll increment my program counter for the next instruction. If not, it is maintained as it is, and my start counter is set to 0, so that it again goes to my fetch instruction. Right.